Dear students, in the mass spectroscopy, we have discussed about the ion sources, and in ion sources we have discussed about the non-volatile substances. Now today we are going to discuss with the non-volatile substances the other method, that is the Californium plasma desorption. The sample to be analyzed in the deposited on thin nickel foil, spontaneous fission of radiation CF252 nucleus occurs, and each fission event gave rise to two fragments. And the California break into the two compounds, barium and technetium. Barium 18 142 and technetium 22 plus 106 with the kinetic energy of 79 and 104 kilocalories respectively. The molecules in two plasma zones are dissolved with the prediction of both the positive and the negative ions. These ions may then be excreted out the source into the analyzer system. CF252 plasma desorption is able to produce better molecule ion signals than FAB fast atomic bombardment and SIMS, that is the secondary ion mass spectroscopy, in the molecular weight range of 10,000 to 20,000 daltons. The second ion source method is mass analyzer separation of ions. The positively charged ions, variants or the fragments produces in the ion chambers are accelerated by applying or acceleration of potential. These ions then enter the mass analyzer. Here the fragment ions are differentiated on the basis of their M/E ratio. The positive ions escalated by the electric field travels in the circular path through the 100-degree under the magnetic field H and fall on a collector, and basically it is the Dempster's mass spectrometer which is having the curvature, and on the curvature separation of M/E fragments takes place. Suppose an ion having the voltage V, then the kinetic energy of the ions are expressed as half mv square is equal to EV, equation number 1, where V is the velocity of the ions after the acceleration. V is capital V is potential applied. Massive ions will be traveled slowly in a circular path compared to the lighter fragments. In a magnetic field H, any ion will experience force HEV. It produces an acceleration of V square upon R in a circular path of the radius R. Hence, from the Newton's second law of the motion, HEV is equal to mv square upon R, equation number 2, squaring both the side. H square E square V square is equal to m square V की power 4 upon R square, or you can write it as a H square E square is equal to m square V square upon R square in the form of the equation 3, but half mv square is equal to EV from equation number 1. Therefore, mv square is equal to 2 EV. Putting the values of mv square in equation 3, we get H square E square is equal to 2 EV dot m upon R square. H square E is equal to 2 mv upon R square, and m upon E is equal to H square R square upon 2V, equation number 4. This equation number 4 indicates that at a given magnetic field strength and escalating voltage, the ions of M/V value will follow a circular path of the radius R. The ions of the various M/V values reach the collector, amplifier, and then recorded. The mass spectrum can be obtained either by changing H at the constant V or by changing V at the constant H. When the magnetic field is varied, this method is called magnetic scanning. When the potential is varied at the constant field strength H, it is known as electric voltage scanning. Now the limitation and modification of this method. The limitation is the Dempster mass spectrometer is that resolving the power is limited by initial spread of translational energy of ion leaving the source. This problem can be eliminated by passing the ion through the electric field prior to the magnetic field as shown in the diagram. The electric field effect will cause the focusing of the ions by placing a slit between the electrostatic and the magnetic analyzer. The ions of closing defined kinetic energy can be selected prior to the mass analysis. The instrument incorporating such a system are called double focusing mass spectrometer, by which the ions of masses can be measured by accuracy of about 1 ppm. It possible to distinguish between the ions which have the same integral mass but differ in exact masses. This may be possible for the isotopes of elements which do not have exact integrated masses. Although the carbon monoxide, nitrogen and CH2 double bond CH, all these have the same integral masses 28. Their exact mass are 27.9949, 28.0061 and 28.0313 respectively. By using a high resolution mass spectrometer, it is possible to separate the positive ion corresponding to CO, CH2 double bond CH2 and N2 etc. In the diagram you can see the source. There is a slit. Through the slit the electromagnetic analyzer will analyze the ions. Again we are having the A slit and then magnetic analyzer. So it is the double filtering, and B slit, through the B slit it will be collected in the collector slits, passing through the electrostatic and the magnetic analyzer. The next point is ion detector. The ions which are separated by the analyzer are detected and measured electrically or photographically. The ion beam currents are of the order of 10 to the power minus 15 to 10 to the power minus 5 amperes. The ion pass through the collective slit one after the other and fall on the detector. The collector electrodes is well shielded from strong ions. The recorder records peak of all the sizes and the mass spectrum is scanned by giving up the scales, and the spectrum is recorded by the same peak and made with the galvanometric having the different sensitivities. Thank you.